Welcome to this iView Robotics video where today we're going to be showing you how to 3D print parts for Develop-Air. Now that Develop-Air is open source, all the parts are available at iviewrobotics.com on our downloads page. So in the event of a crash, you can rebuild Develop-Air, you can make your own upgrades and modifications, and even, just build Develop-Air from scratch yourself. Now let's take a look at some of the 3D printed parts on Develop-Air. I guess starting with the motor mounts, that will be one of the parts that we show you how to print. So you need 4 of those for each Develop-Air. You similarly have 4 feet on Develop-Air, a couple landing gear brackets, battery brackets to hold the battery in place, the payload bracket to attach your payload to down at the bottom, and then there are some parts in the fuselage. But otherwise, the big main parts are the fuselage itself that's 3D printed and the top cover. And then all of the other parts are like fiberglass in the case of the boom arms and landing gear. But that'll be the topic of another video. So let's put this Develop-Air aside for now because quite frankly, we have access to a lot nicer 3D printers than probably what most of you have in your schools or even just individually as hobbyists or enthusiasts. While Develop-Air is printed either using nylon, polycarbonate, ABS, or ASA materials here in-house, we've also done prototyping on Ender 3 printers that are really only capable of printing materials like PLA or PLA+. So let's take a look at some of those just so you can be assured that Develop-Air is not too complex for you to print on an off-the-shelf printer like an Ender 3 or a Prusa. So here is an example of a top cover for Develop-Air that was printed in a PLA Plus material, also again on an Ender 3 printer. You can see it's not quite as pretty as some of our new 3D printed parts, but functionally speaking, this will be more than enough to at least get some flights under your belt and do any sort of prototyping that you need to do. Similarly, here are some prints that we've just printed out in ABS, but looks-wise, they should be identical or nearly identical to anything that you print in PLA. And then lastly, speaking of PLA, we have this Develop-Air fuselage that again just goes to show that you can build a whole Develop-Air using PLA parts, and again may not hold up as well to some other materials like we're able to print with now. But as long as you're not leaving Develop-Air out in the sunlight or out in the car where it's going to warp the plastics, PLA Plus should be more than fine. So now that you've seen some of the materials that we've printed Develop-Air with, let's go ahead and take a look at the computer, show you where to find the parts, and then how to print some of those parts. Now that we're back on the computer, we are on the iView Robotics website. We are going to want to navigate to the downloads page. So if you go to iviewrobotics.com/downloads directly, you'll end up here, or from the home page, just select resources, then downloads. Scroll down to the hardware section where you'll see the 3D printable files, the 3D design files, and the parts list. We're just going to focus on the 3D printable files right now, so go ahead and select that download icon next to it. That'll bring you to this Google Drive folder that we have with all of the open source 3D print files for Develop-Air. So let's start off with the boom arm, where you can see there's a motor mount file. There's just one 3D printed file for the motor mount. So let's go ahead and download that. Once it's downloaded, you'll be able to load it into your favorite slicer software. If you're not familiar with what slicer software is, it's essentially just the software that your 3D printer uses to take a 3D model, break it up into hundreds of different layers, maybe even thousands of different layers, and then just print it layer by layer, right? So Bamboo Studio is the slicer software we'll be using since we use a 3D printer that they make as well. I did see it is compatible with 3D printers outside of the ones that they make, but you'll just want to download the software and see if it's compatible with your 3D printer. Otherwise, you can also use the Ultimaker Cura software. That's what we started out with before we got our new 3D printer, and this works just as well. More or less what I'll show you will be carried over between the slicer softwares. It just may look a little bit different. So now that we've downloaded the 3D motor mount file, we're just going to go ahead and drag and drop that into Bambu Lab here. Once it's loaded in, it's just defaulted to a vertical orientation, which outside of the material that we're using, in this case ASA material, the orientation of your part can also have a big effect on its structural integrity. And then otherwise, you'll also want to adjust like the layer height, for instance. Here are some presets available in this software. We're just going to go ahead and select ones that make sense for us. We have a 0.4 millimeter nozzle, and so you can see the standard layer height is 0.2 millimeters. We're actually going to do what's considered optimal at 0.16 millimeters. We're also going to enable support. We'll cover a little bit more of this later, but before we do, let's go back over to the Strength tab and cover some other areas that you're going to want to adjust the settings for to make sure that your parts not just come out looking good, but they're also structurally integral. Looking back at the footage, wanted to make a couple of corrections, or actually a couple of recommendations here on the Strength tab. So you'll see the top surface and bottom surface patterns are automatically set to monotonic. We actually want to change those to be rectilinear, just like the internal solid infill pattern. This will make your part stronger in both the X and Y direction. While it won't really have an effect on the Z or vertical direction, the orientation of your part will help you there. So let's go ahead and drop those down just over to rectilinear. If it's not already set by default, you'll want to also adjust the top shell and bottom shell layers to 4. Any more than 4 walls is probably, more than fine, but just know extra material is going to mean extra weight. And with something like Develop Air, a drone, all the weight you can save, the better. And similarly, you could also adjust the wall loops to 4 if you're finding the parts are not coming out strong enough for your liking, but we found that just 2 wall loops is more than sufficient. And then lastly, down here all the way at the bottom, you'll see the sparse infill density. We're going to change that to 40%. Now, using ABS or ASA, that is more than enough. If you're using a weaker part, maybe like PLA, you may want to use a more of an infill, and this is just going to make it so the more infill, the more plastic in your part, the less infill, the more air in your part, right? So how hollow is the part? And then as far as the pattern goes, we found that gyroid is the strongest pattern, but these are all of the characteristics that you're going to want to choose when you're printing parts for Develop Air. And then now we can just go back over to the support tab and then finish the orientation and support settings, and you'll be off now printing your first motor mount. Going back to the support tab, as I mentioned earlier, now what we do is something a little bit more advanced than what most 3D printers support. We are actually going to print with another type of material for our support. Even though it says generic ABS up here, you can see we actually have 4 different types of materials available to print with at any one given time, thanks to our printer. But we're just going to print using 2 of them. The main material, which is ASA, which is essentially ABS, which is great for high impact resistance and durability and high temperatures. But ASA is also better for outdoor environments, for like weather exposure, water, moisture, and then UV. So we're going to select ASA. And then even though it says generic ABS, this is actually just a placeholder for a type of material we're using called HIPS. Again, a little bit beyond, I think, the kind of intro or basics of 3D printing. But some support materials you can actually dissolve, some in water, or in the case of this HIPS material, you can use a chemical called D-limonene, which, fun fact, is actually just an oil that you get primarily out of orange peels. But outside of the materials that we'll be printing with, we're actually just going to change the orientation of this motor mount. So you can see it's vertically oriented right now. We are just going to rotate it so it is now laying flat. You can do so by clicking the rotate tab here, or in some slicer softwares, most slicer softwares, you can actually click lay on face, click the face you want it to lay down on, and then now you can see this is in the proper orientation for how we want to print it. Now the last part to do here is just selecting slice plate. Again, this will kind of break the model up into a lot of different layers. And in our case, we're going to see it change filaments. I think that says 50 times from here. And you can see, I think it's 127 layers, but it'll take 2 hours and 42 minutes to print. Now this may vary depending on the printer that you're using, but now we're just going to hit print plate. You can name the file if you want up here. You can change the filaments if you want last minute. Otherwise, we're just going to hit send. I'll send it to our 3D printer. And our printer is actually nice to where we can actually get a live preview, a video feed of the printer. So we'll show you what this motor mount looks like when it's done. And I think in the meantime, you'll see a time lapse of this print in progress. Our motor mount just finished printing, but before we go remove it, just a couple of tips you might find helpful. We have these little like spatulas, for lack of a better word. I also recommend having a bigger one, kind of like what you would use for applying drywall or spackle onto drywall. But these make it very easy to remove parts from your printer if you're having a hard time getting them unstuck from the printer bed. And then lastly, we'll cover this once I actually grab the motor mount as well, but here are some tools that we find are very helpful for removing support material. If you've bought an Ender 3, these probably look very familiar. These are clippers that you get with the purchase of an Ender 3, and just some basic tweezers and some needle nose pliers typically do the trick. And, of course, your hands are a great tool as well. But let's go ahead and grab that motor mount and show you how it came out. So our bed had already cooled down quite a bit, so it was pretty easy to just pop off this print. As you can see, it came out pretty nicely, but there's still some support material to be removed. We'll go ahead and remove that, at least see what we can do via our hands right here. You can see it comes out pretty nicely. Again, we're using a material that's made to be a support material. You might not have as much luck if you're using PLA support material with a PLA print, or ABS material with an ABS print, but quite frankly, PLA is pretty easy to pry off, even if it's the same material if you're printing with. So there's most of the material out. You could still see there's a little bit more in here that we can grab out with the clippers. But all in all, I mean, that should give you a good overview of how to print parts for Develop Air. Now that you've seen some examples of 3D printed parts, both from our past using, kind of more basic 3D printers and the materials, you've seen how to download our 3D printed parts from our website, and you have gotten an overview of all of the 3D printed parts on Develop Air. But of course, if you have any questions, feel free to leave us a comment in the comment section below, or join us on our Discord server, where us and our community of developers, students, and enthusiasts would also be more than happy to help you in any way we can. Thank you.